Hello, everybody, and welcome back to another episode of EOXS's Stories on Steel. This is a steel industry podcast featuring the big names of the business and the advice/stories they've accrued over their years as insiders. Steel has been a vital component in American life for well over a century, and the men and women who've helped it flourish are a diverse group of innovators full of fascinating tales. We hope to share some of said tales with you today. Thanks again to EOXS for providing this platform. In addition to this show, they are bringing businesses online by providing a standardized digital workspace for all your steel-related needs. Today, we welcome member of the board of directors for US Vanadium, Terry Perles.
Good day.
Thank you so much for joining us, sir. How are you doing?
I'm doing very well. It's a brisk day here in Pittsburgh, but other than that, everything's great.
You guys getting snow yet?
We had a little dusting this morning. It's hard freeze the last couple of mornings, so we know what's coming here.
Yeah, I just drove down from Buffalo back to Jersey, so I've all through Pennsylvania, seeing the various elevation levels, how the snow is starting to pile up, and I'm just getting my shovel ready.
Right.
It's one of those days. Before we get into your company, I'd like to change up the format a little bit and start talking about you. How did you enter the steel industry?
Well, I was born in Detroit, but I grew up in Pittsburgh. And if you grew up in Pittsburgh in the 70s, you or your family or somebody in your family was involved in the steel industry. So really my first job was working at the US Steel plant in Homestead, Pennsylvania, in the open hearth of all things. Don't think there's any of those left here in North America anyway. That plant was built in the 1870s, and I started working there in 1981. Worked at the Clairton Coke Works up the river, another U.S. Steel operation up the river here in Pittsburgh. So that's how I got started in the steel industry originally.
Were any other members of your family involved in the steel industry, to your recollection?
No, both my grandfathers who lived in Detroit worked in the auto industry. So one grandfather was a machine shop. He ran the machine shop, working on the machines, keeping the assembly lines going, and the other one was a security guard at the River Rouge plant of Ford, which was actually a steel mill as well. But that was really the only steel related work for any of my relatives.
So,
but if you live in Pittsburgh, you're one way or another, you're going to be involved in the steel industry.
Either the steel or the pirates, just it's one of those two pipelines.
Exactly.
So what was the career path that led you towards vanadium before we get specifically to talking about your current company?
Yeah, so I'm an engineer by education, and I worked as an engineer for several years in the early 80s. If those of you that are as old as me will remember that this was the time period when the steel industry was just collapsing here in North America. We started to see a global market for steel for the first time and started to see competition. At that point, it was competition from Japan, but the ramifications on the U.S. steel industry in the early 80s were severe. So I decided to try and move on a little bit from the steel industry and really just got involved with vanadium by answering a help wanted ad in a newspaper. I'm not sure those exist anymore, but 1986, that's when I stopped working in the steel industry and moved into working with a company called Stratcor, which was a vanadium producer here, a spinoff from Union Carbide, who had operations in Niagara Falls, in Hot Springs, Arkansas, and in South Africa.
Just for a point of reference, as a freelance media personality, I can in fact confirm that help wanted ads in the paper do exist, and I am very much frequenting them. Now, before we get into the company, I think the chemical or the element in question is probably a topic of great interest for a lot of people. So what can you tell us about vanadium pentoxide? Am I pronouncing that right?
Yeah, vanadium pentoxide is the most predominant form of vanadium oxides that you'll find out there. Vanadium is element number 23 on your periodic table. It is a metal. It's a very unique metal. It's a transition metal, and it's happy and stable in several valent states. And because of that, vanadium is tremendously useful as a catalyst. For example, for production of sulfuric acid, oxidation of SO2 to SO3 over a vanadium pentoxide catalyst. There's a lot of pollution control catalysts to eliminate nitrogen oxides and sulfur oxides from flue gas emissions because of the fact that vanadium is stable in +2, +3, +4, and +5 states of valence. So it can give up electrons and take electrons freely, which is what you're doing in the catalytic reactions. So that's an important part of vanadium's role in the economy. Vanadium is also broadly used in titanium alloys. So be it your golf club or your jet engine, typically you're going to have about 4% vanadium in those alloys. For rotating applications in jet engines, vanadium gives you higher strength and creep resistance, which are important parameters in a jet engine. So titanium alloys take about 5% of the world's vanadium. Chemical applications take about 5%, but 90% of the world's vanadium is used in the steel industry. And in the steel industry, you've got two types of steels that consume vanadium. One is high alloy or tool steels, very special steels with very high levels of elemental additions like vanadium, nickel, chrome, molybdenum, cobalt, on and on. And those steels are produced for very specific needs. The other and larger application for vanadium in the steel industry is in a class of steels that we call high strength, low alloy steels. And in these steels, we make a very small addition of vanadium, typically 0.05% vanadium in the steel. And the vanadium will have a very significant impact on the yield strength of the steel. And it depends on the application, the product, but in many cases, you can double the yield strength for a very, very small addition. So it's a very cost-efficient way to produce very strong steel. And if you think about steel, steel is the backbone of infrastructure that's required to create economic opportunity. And in the developing world, you see this trend of very high growth in steel production as economies are building their infrastructure to allow the economy to grow and to create economic opportunity for people. The problem is there's a lot of negative impacts of this surge in global steel production, from consumption of raw materials, consumption of energy, generation of pollution, and consumption of capital invested in steelmaking capacity. And all of those negative issues can be mitigated to some extent by replacing low strength carbon manganese steels we've been producing for the last 150 years and replace those with microalloyed steels that use either vanadium or niobium or titanium or some combination of those three elements to dramatically increase the yield strength of the steel in a very efficient manner. This allows developing countries to build out their infrastructure with a minimal consumption of raw material and energy, minimal pollution generation, and a minimal amount of capital deployed in steelmaking capacity.
So there's a lot to unpack there, but would you say, based on all of that two of the major benefits that you see from the work that US Vanadium is doing are economic, like a huge boon to developing economies, and also ecological, as in like reducing harm on the planet, making use of less material? Does that sound about right?
Absolutely. When you look at for example, the CO2 footprint of the vanadium industry, and how you go about making these calculations is paramount. But I can make a strong argument that the vanadium industry has a very large negative CO2 footprint. For every half a kilo of vanadium that you produce and put in steel, if it doubles the yield strength of the steel, that means 1 ton of steel doesn't need to be produced. And when you go through the numbers, it's astounding. As an industry, we're just getting ready to start putting out some data on the intensity of pollution from the industry, and I think there's going to be some very interesting statistics put out there. But the basic role of using vanadium to produce high strength steels to allow the developing world to build their economy and create economic opportunity for the poorest people in the world is incredibly important. And I think vanadium is a keystone in that process.
When you're talking about developing economies and developing areas of the world, do you have any particular regions in mind, or are you speaking generally?
Well, I think you can just look at steel production on a country by country basis and see what's happened in the past and what continues to happen today. Obviously the big stories in China was steel production, now over 1 billion tons of steel a year in China, coming from, next to nothing 20 years ago. And we see the same thing now happening in India. India is now the third largest producer of steel in the world, behind China and Japan, and just ahead of this US now, I think, actually. And you can look at, the rest of the developing world, be it in Africa, Southeast Asia, CIS countries, where you see governments that are investing in infrastructure to create economic opportunity. Those are the places you see this tremendous growth in demand for steel and some of the negative consequences of that as well.
It sounds like there's a lot of problems that are being tackled by US Vanadium right now. What was your knowledge base of these issues before you became involved with the company? Were you aware of all these problems? Is this like a very commonly known issue in the steel industry, or was it more of a let sleeping dogs lie and then you suddenly became aware of it?
Well, I guess I've worked almost exclusively in vanadium since 1987, so that's my background. Vanadium bearing steels are a relatively new class of steels. Really, you go back to the late 60s and early 70s when people started producing these high strength low alloy steels. So it's a relatively new product in the big picture. But the vanadium being used in steel started off really as an economic advantage to the steel makers, an economic way to produce higher strength steel, and has grown from there. So, my alleged knowledge and understanding of the industry is a function of spending the last 32 years working in this industry. I'll mention another thing I didn't mention before, and that's in the future, there's a lot of very interesting things going on in terms of vanadium applications. We see vanadium is critical today to the defense industry because of the fact that you don't have jet engines or ballistic missiles or titanium alloys and armor without vanadium. You can't make those alloys. There's some very, very interesting things going on in terms of energy storage. People have heard about vanadium flow batteries for a long time, but you're now starting to see that technology reach a point of maturation where it becomes very, very, very competitive with lithium ion batteries. And when you look at grid level storage over long duration periods, there's a very strong economic case for vanadium batteries to support the renewable grid in conjunction with solar produced power. And there's some other very interesting work going on in the future, replacing I think the next generation of intercalation batteries won't be lithium ion batteries. They're going to move on to calcium and magnesium, where you can get 2 electrons for every atom instead of 1 from lithium. And in those systems, there's a role for vanadium in the cathode of those batteries.
I think as we're starting to see more electric-centered modes of transportation, specifically cars, battery storage is definitely going to be looked at a premium. Any solar applications off the top of your head, or?
So not per se to produce electricity from solar, but if you think about renewable, whether it's solar or wind, the problem is the intermittent nature of these sources. So a good example is Southern California, where you have a lot of large solar farms, as well as individual homeowners having solar systems installed. And you do see many times in the summer, the demand on the grid go negative in California. There's so much solar power being produced that the grid can't consume it all. And the electrical power system is the largest distribution system in the world with no warehouse. You have to instantaneously produce and consume electricity at the same rate. And this creates a problem now. If you look at the demand for power during the day, typically you see a minor peak in the morning, relatively flat consumption during the day, and then a massive spike. The peak demand occurs now in California at 8 o'clock at night. And then, of course, in the nighttime, the demand is fairly weak. But because there's no storage, you have to instantaneously produce power to meet that peak demand. So you have to maintain peaking plants that typically are burning gas, and they come on at 5 or 6 o'clock in the afternoon and they go off at 9 or 10 at night. They're very expensive to maintain and operate, but that's how you meet that surge in power. If you can couple these vanadium batteries together with the solar powers, you collect the power you can produce and don't need in the middle of the day and deliver it to the grid 8 hours later. There's incredible value and utility there. And that's when you start talking about 4, 6, 8, 10 hours of storage, lithium ion becomes cost ineffective at those numbers. And that's the sweet spot for these batteries. So that's what we're looking at. And then, the next thing people are looking at is not just load shifting from the middle of the day to the peak at night, but load shifting seasonally, producing a lot of power using solar panels in the summer, storing that energy for 6 months and delivering it back to the grid when the sun isn't shining as much in the winter. And again, you think about the utility and the impact on the cost of maintaining assets and operating those assets to supply power to the grid. There's tremendous value there. So that's something that has been around for a long time. It's always been that market where we always say, pay attention, make sure you know what's going on there, but you can't bet your business on this market because it's really not much of a market today, but it might be a tremendous market in the future.
This is entering very exciting territory, to be sure. Now, one thing that I've learned from my experiences communicating with leaders in the steel industry is that at every level of manufacturing or development, not all substances are created equal. And on the US Vanadium website, a big push right on the front page is the purity of the element. So what does the production process look like for vanadium?
So there's really 3 primary sources of raw materials that are used to produce vanadium. We have deposits of what we'll call vanadium titanium magnetite. This is magnetite deposits with typically with 10 to 15% TiO2 content, and then a little bit of vanadium, anywhere from 0.2 to 1% V2O5 in these ores. And these types of ores exist broadly around the world. Vanadium is, I think, between the 17th and 22nd most abundant element in the Earth's crust. So there's more vanadium than there is things like lithium and chrome and cobalt in the crust, but it's just rare to find it in economically viable concentrations. These vanadium titanium magnetites are typically the ores that are used to produce vanadium. And if you go to Russia and China, the steel mills there were set up to utilize this ore because that's what they had when they built the steel mills in the 1950s. So in Russia and China, you have steel mills processing this ore and generating a vanadium-bearing slag as a byproduct. And that slag becomes the raw material for production of about 70% of the world's vanadium. Another 20% of world vanadium is mining of these vanadium titanium magnetite ores and directly extracting the vanadium from those ores with no steel mill involved. And then the third leg in the supply chain is what we'll call secondary materials. Typically oil coming out of the Caribbean Basin, parts of the Middle East and Russia contains vanadium. And when that oil gets burned or refined, you end up with vanadium concentrated in some sort of a waste, or if it's burned at a power station and with fly ash and boiler slags. and those vanadium units can be recovered. So there's three primary sources of the vanadium. In all cases, you're going to take this vanadium and you're going to solubilize it. You're going to leach the vanadium into solution, and you can do that either in a caustic leach or an acid leach, depending on the process you're using. Once you've got the vanadium in solution, some people will go through solvent extraction, ion exchange to purify that pregnant liquor. Most people will not, because frankly, the steel industry, vanadium's a commodity. We're adding 0.05% V to the steel, so the purity isn't really that important in the steel industry. But either way, we end up with a pregnant solution. We drop the pH to a point where the vanadium solubility reaches a minimal point, and we'll start to crystallize a vanadium salt, ammonium metavanadate, and then we'll calcine that to drive off the ammonia, and you're left with V2O5. So it's a hydrometallurgical route, regardless of the raw material. And most of the industry is set up to produce commodity grade material, which is typically 98% purity for V2O5. Our business is a little bit special because of the technology we have at the Hot Springs, Arkansas plant. We can all day long produce extremely high purity vanadium, 3 or 4 nines purity. And it's desirable in the titanium alloys and in the chemical application. So that's where we try and focus most of our efforts.
Are there any common issues that would interfere with that high grade purity that you guys strive for?
Well, the fact is there's only about 3 plants in the world that are set up to produce high purity V2O5. So the number of producers of the material is limited. The market's somewhat limited as well, but it's kind of a small space that we live in. The applications are such that we have to have extreme assurances that there's no way for any refractory materials to enter our production line. That's critical, because if we get any high density materials in a turbine blade on a jet engine, that's disaster. And so we have incredible controls in terms of making sure that doesn't happen. If we do any welding with TIG, tungsten inert gas welding in the plant, we make sure we count the number of welding rods that go in and count the butts that come out, so there's nothing laying around. Nobody's allowed to bring their phone or a ballpoint pen into the plant, because this little tip on the end of the pen is tungsten carbide. And so there's no tungsten filaments in any of the lights. And so you have to go through extreme precautions to ensure the integrity of the product that's going into those sorts of applications.
You spent a lot of time on this discussion listing a ton of the really exciting uses that you see coming down the pipeline for vanadium. To keep up with that demand, is there any big need for innovation from your part, or are you just waiting, or are you guys just waiting for the world to sort of catch up and utilize vanadium more?
I think, the vanadium consumption has grown tremendously in the last 20 years, both in the steel industry and in other applications. And with, the potential for these new applications, particularly energy storage, depending on who you believe, you could see a massive growth in demand for vanadium in the coming years. Now, I'll add the caveat that many people have been saying this for a long time, but I do think we're now at the point where you're seeing the confluence of the development and maturation of the technology, along with the growth in a long duration storage market actually occurring today. So as you look ahead, the question is, where will the vanadium come from? And it's really not the right question. There's the question of, is there enough vanadium available? The answer is yes. Again, it's the 17th most abundant element in the Earth's crust. But to produce vanadium, it's capital intensive. A lot of the vanadium produced today is a byproduct or a co-product from steel mills or power plants. And there's only 2 world-scale vanadium primary mines in the world, 3, 1 in Brazil and 2 in South Africa. And, there's going to be need for more investment in this industry looking forward. There's dozens and dozens and dozens of potential projects out there. but they're all struggling to find capital to support those projects. So it's possible we're going to see a pinch point in the not too distant future here.
Do you think that comparing it to whatever role it currently occupies in the economy of vanadium, do you think e-commerce will grow to have a greater impact on your business or stay the same?
Well, I think that, e-commerce and technology is always going to have an impact. I mean, look what we're doing right now, huh? That's a good example. And the vanadium market is multifaceted. You've got some very special applications where a lot of hands-on and strong relationships between producers and consumers are necessary. And then you've got kind of the commodity side of the business, and how that relates to e-commerce will be interesting to see. I can recall, I don't know what it was, 20 years ago when some of our customers started, rather than negotiating contracts every year or 2 years, they went with a reverse auction process, right? That sort of process never took off in our industry. It just didn't get any traction. There always seems to be a need to have some personal relationship to push this business forward. Now, that's not saying e-commerce and technology isn't important. Obviously, it makes our ability to communicate so much more efficiently and exchange information. But I think you're always going to have a little broken down salesman like me hanging around in the vanadium industry.
I can only hope. I can only hope. I think that's a great lead into one of the other questions I had here, was that from these conversations, I've really gotten the sense that in spite of all the change currently going around in the world, the cultural shifts, steel is still seen as one of those bedrock industries that is resistant to change. It's more traditional. So I would assume that you agree with that point of view.
Yeah, absolutely. I mean, it's as I said before, it's the backbone of our economy. The steel allows you to create the infrastructure that creates economic opportunity, and it's important economically. It's important in terms of national defense, and the steel industry it's a little bit addictive. You stand there in front of the furnace and watch the furnace breathing and living. It really kind of draws you in. So the steel industry is, particularly here in Pittsburgh, this is what we do, and we take it very seriously.
Taking steel seriously and throwing tomatoes at the Patriot bus whenever it comes to town.
Patriots, Browns, Ravens, doesn't really matter.
I mean, hey, I can't really blame you. Ever since Brady went to Florida, I haven't been the same. Well, let's take. I think it's important to cover this just because it's such an important part of our lives and in history right now. COVID-19. It's rocked every single facet of the global economy. Socially, politically, it may be the biggest thing a ton of us live through. How has it affected your company, and what changes have you had to sort of make on the fly besides more Zoom meetings, I would assume?
Yeah, well, like everybody, that's the case, but it's had a tremendous impact on our business, particularly on the logistical end. We've got a business here where we're bringing raw materials into this plant, some of them from the US and some of them from overseas. And, you're talking about tens of thousands of tons of material moving. So the COVID had a very significant impact on our ability to move material and get raw materials into our plant, as well as to get final products out of the plant. In terms of direct impact, I think we were very lucky. As far as I know, we've had one positive case at our facility through the whole thing. We're fortunate that we're in Little Rock, which is not a huge urban center, and the impact of the COVID in that part of the state has been somewhat mild compared to other places. So from a personal standpoint, it hasn't had a huge impact. But in terms of everything from moving material to to being able to raise funds, to everything else has been dramatically impacted by the COVID. And when you're in the metals industry, the steel industry, you've really got a situation where China is driving a lot of the growth in supply and demand. And you look at what happened in China in the first quarter, the steel production dropped precipitously, but they recovered very, very quickly, and they're back now producing more steel than they ever had. Whereas if you look at the West, we see a much more protracted situation. The production of steel bottomed out in April, and it's climbed back from there, but we're still not back where we were before the whole COVID production issue. So the virus has had a different impact on people depending on where you're at, but it's been severe for everybody. I can assure you that.
Has the recovery for vanadium been going smoothly?
It's been going. It's been going. I won't say smoothly. Again, if you look, you can kind of, because 90% of the vanadium goes into the steel industry, you can kind of look at steel production as a proxy for vanadium consumption. And if you look at that, you look at those numbers, you see the wild ride we've been on this year in terms of steel production tanking in the first part of the year and now coming back. So again, in China now, they're back above where they were. Consumption of vanadium is well beyond where it was this time last year. In the West, we're still struggling. We're still seeing steel production below where we'd like to see it. I think World Steel suggests outside of China, steel production this year is going to be down about 18% compared to last year, and that has a huge impact on the consumption of vanadium. So it's moving in the right direction. We spend a lot of time looking at the vanadium numbers, the fundamentals, trying to understand what's going on from supply-demand standpoint. Clearly, we built inventory in late 2018, 2019, and the first half of 2020 due to a number of things. We had a huge price spike in 2018 that caused some substitutional loss of demand, and then the COVID issue. But we've entered now, as of the third quarter of this year, a phase where we're burning inventory off. And the question is how much, quote, excess inventory is out there in the pipeline before the market's going to react.
All right. Terry, we're out of time right now, but I want to thank you very much for all of your wisdom. This has been an incredibly insightful conversation, and we hope to have you back if possible. All right.
My pleasure.
Thank you very much. You have a good day, sir. Sorry, the Zoom call's about to conk out, so I gotta be
okay. Very good.
All right. You have a good one, sir.
Thank you.